So as a lot of you know, this was for our NTC welding competition at school. We made a scalloped hammerhead shark out of 22 gauge steel. We MIG welded all of it. So we started off brainstorming by researching a bunch of welding sculptures online over the summer, and then we narrowed down some options to some kind of animal sculpture. We had talked about like a elephant head, a lion head, like some kind of just fish, sharks, stuff like that. Once we both figured out we had an interest in like marine animals, we decided on a shark, and we researched a bit on endangered species and really intriguing species. So like the hammerhead shark, it has its very detailed head. The thrasher shark has its really distinctive tail at the end, like the really long swoop to it. So we really just wanted to do something really detailed that would kind of stand out more. And we finally picked the scalloped hammerhead shark.
All right, well, so materials, wood base was actually supplied by my family. My parents, we cut out the material, and we also laser engraved the sign up here in front. The redwood that you see right here is called as a paduke, and then the white wood right here would just be normal plywood. And then the tools also it's the same, 22 gauge metal. And then the tools that we use were provided by one of 3 shops. We're provided by one of the 3 shops. So we actually worked at Mosinee for most of the time. We worked here a little bit, and we also cut out the used C-Tex laser or water jet to cut out like the skeleton for the shark. 22 gauge cold rolled steel, and we also had some rebar that we found lying around in the Mosinee shop. So.
Good. So we had started this in September of last year.
Yep.
So it's been quite a few months. We started off just kind of brainstorming and printing off images online to kind of trace out shapes in them that we saw to figure out how we'd section everything together. And once we got that figured out, we actually contacted Mike Whitburler at work to ask him if he'd be willing to help us get some material and use the water jet down at C-Tech. Once we got that all cut out, we brought it back, and we were drawing out sections and cutting out all these individual squares and stuff, and just long section pieces that we were bending by hand over vise with just mallets and brute force, basically. So it took a while. And we repeated all of this until we got it done. So
So getting started, discuss materials in general, processing. I mean, this thing was pretty difficult to go into, so like we had to brainstorm quite significantly in order to actually get anything started, and that's where the idea of using C-Tech's water jet to cut out this guy right here is what we pretty much cut out, and this slit right there is actually like this horizontal plane, so like where these fins are, and those were 2 separate pieces, so we actually used their water jet for that. We printed reference images so that we could have like an idea of what the shark would initially look like in like the 3D view, I guess. And then, created a sketch and inventor as co-worker if they would be willing to supervise our work at the facility. I mean, but like we used C-Tech's water jet, which was really cool. I actually really liked watching that. That was pretty cool to look at. But that was pretty much the getting started portion of that. A lot of planning.
We talked a lot about going to C-Tech and getting everything cut out. It took a while to get there because we had a lot of conflicting ideas on how the base should be, but once we figured that out and we got there and we talked to Mike, we agreed that it would be best to kind of do like that planed out piece and section so that everything could just be put together like this. And we got to learn all kinds of cool stuff. We got to learn how to program in the file to run it. We got to run it ourselves. We got to see how to run maintenance on it because somebody didn't use it correctly before us. But it was just a really great experience all around. We got to learn new things, and we got to do like cool stuff before we even started. So it's just been pretty cool all the way around.
And then the gathering pieces part, this was probably the most difficult thing. We had to cut out everything by hand pretty much. we used the leftover sheet metal to use leftover sheet metal to create the body and the fins and stuff like that. It was kind of just a lot of back and forth and just kind of slotting things in where they needed to be, and like so I'm just going to explain like the
So the main
layouts
idea
here.
for all of it is we knew what we wanted. We knew we needed fins. We knew we needed pieces. We just didn't know how we were going to get them in there, and we had limited material, so we didn't want to just start chop sawing it and decide like, oh, that doesn't work. So we were drawing everything out by hand on paper, measuring it out, sketching it onto the metal, and then a lot of it we were just cutting with tin snips because we couldn't get in there with any other of the saws and stuff we had at school, because unfortunately we didn't have the greatest tools to be working with a majority of the time. So, and that's where like C-Tech and the hangar here came in. We'd come in and you guys let us use a lot of the materials we needed, tools we needed to get this done. And we do appreciate that a lot, because once we got pieces cut out and laid out and all bent up by hand and started connecting them, that's when it really, really got hard. Because again, like, you're bending all of this by hand. Like, we try to use anything we could to make it quick to cut out, but then as soon as it got to the bending, it was a whole nother beast on its own. Like, that's individual sections that we had to specifically cater to the edges on the shark. So that took a while, and then we were welding on MIG, which we realize is probably the worst way we could have welded this. It took a while. It's on thin material, and MIG isn't exactly set up for welding something with this much detail. TIG probably would have been better. We realized that afterwards, but in the end it was a really good challenge because we were able to see how to kind of adapt when what you're doing isn't working and trying to work around what you have going on. So in a lot of spots there are some beads where, maybe this one, where they're not the best beads, but it was a lot of practice with like trying to get a full one before it would burn through, figuring out how to fill in those burn holes, and just kind of figuring out how to patchwork the whole thing a lot of the time. So we do have like a whole photo gallery if you guys wanted to see that afterwards, but it's just documentation of everything we did throughout it, because it is one of the requirements of NTC. So any chance we could take, we took pictures and we sorted them out. So we have, I think, at least 120 pictures in there of everything we did. So there's plenty of documentation if you guys are interested in that.
Oh yeah, challenges. Now look at that. So first off, before we even started this, we had come into this absolutely not knowing each other at all. So she approached me that next Monday after Memorial Day, and she came to me and she asked me if I wanted to partner up with her in a project, and I said I wasn't working on anything, so yeah, sure, I'll do that. And then so we kind of, I guess it worked out, And then the process of construction was also incredibly difficult. Because we didn't really know how to form sheet metal. I've never really had experience in that, nor probably has Mya.
No,
so
neither of us really knew what we were doing.
Yeah.
It was kind of just working as we went, and there were a lot of steps we started getting into, and we're like, this is not time efficient, and kind of just had to abandon it altogether. So
yeah, and then the time frame was pretty. I mean, we didn't really have such a strict time frame, but we did want to get it done before the competition. And it was kind of a lot of stress that kind of put on both of us with the whole trying to get this done before a specific time. Material formation, I would say that's probably the most difficult thing about it, because everything that you see here, like all these little slits right here, we actually had to make in the material to be able to bend it the way it is, because sheet metal does not bend that way. Because if you try to bend a flat piece of sheet metal, what is it doing?
I've made it worse.
Okay.
We'll just pretend it's fine.
Okay, yeah, so trying to bend a flat piece of sheet metal in two different directions is incredibly difficult, because then it just likes to do its It's just like it doesn't want to cooperate, so we had to make relief cuts in the shark. We had to make relief cuts in these sections over here to be able to actually bend that in the directions that we needed it to go. So that was pretty difficult. That was a new learning experience. I did not know we had to do that, but I don't know. That's learning experiences. Material thickness was another big thing because, like Mya said, we kept burning through it when we were trying to weld it, and I mean, it kind of got to a point where the welding part took the longest time because we would weld a very small portion of it, and then we'd have to stop because the material would get too hot, and it would just burn right through for it to continue. So we had to kind of jump back and forth between that. Now, I did find that, like, for welding, like, usually if you're trying to weld on material this thin, you want to use, if you're trying to use a MIG weld on this specific thickness, you want to use 75-25 CO2 and argon, because argon does not trap in all that heat into that one spot, so it allows the heat to disperse a little bit so that it doesn't get super hot. So yeah, and then the details was also another pretty difficult part, especially the head part. That was, I mean, we kind of rushed that a little bit because that was more towards the end. But the tail part, we actually spent the whole day when we came down here, we spent the whole day figuring out how to get that tail to look the way it is. And I thought it turned out really well, so.
Yeah, there's about 6 hours on its own with like these little pieces and bend-ins on the tail. So it took a long while, and it was a lot of trial and error and learning things that we never thought we'd even like. We didn't even know it was a thing that you could learn. We didn't know walking into this a lot of what we were doing, so it was a huge learning experience all the way around. But I think that's honestly my favorite part about it. It maybe didn't turn out the way I exactly wanted it to, but I got to meet a new friend, learn to communicate on a project that you're both constantly frustrated with, and learn how to work with things that you're not used to working with, and working around things that aren't easy to do. So, but yeah, I think that's it. So I don't know if you guys have any questions at all, or.
So this is all done at TC then?
This was done at the school.
Yeah.
Mosinee High School.
Mosinee
You
High
would've
School.
been better off doing it here.
Yeah.
We probably would have been better off doing
Yeah.
it here. We would have had more time to work on it. Because that's another thing as well. Like,
You have better equipment here.
Yeah, we do have better
yeah, because
equipment here.
that was actually another big challenge in here. That, like, we didn't have any time at school. We only had 45-minute class periods. So once we started something, by the time we actually got working on that, the class would be over, and we would have to stop, and it would just be this constant on and off thing, and that kind of really drew it out a lot more than it really needed to. Whereas if we were to just, like, spend a day somewhere where we had the materials to do so, like here or someplace, we could just bang out one entire section and then not have to worry about that again. So that was another big struggle with the actual time frame part of it, and only having 45 minutes a day to work on it. So
Did you ever consider the plasma cutter for making your small parts?
So the problem is the small parts we're talking about are about like this. So doing that on the plasma cutter on 22 gauge steel, that will burn right through what we're doing and melt everything. So everything was, the majority of it, cut out by hand and ground down into finer detail so that.
Did you consider the English wheel as a way to bend sheet metal?
we did. We have one. It's just that the parts in which like these big sheets on the top here were too long for it.
They wouldn't fit it?
They would not fit in there, so.
Yep, and with that too, this whole top piece is one piece. Like, these are just relief cuts put into it, so every individual section, even on the sides of the section, all have different bends to them. So you can't just run it through and be like, okay, it's perfect now. Like, it was a lot of like detailed, curated bends and like forming, so.
What's your next fish?
I don't know.
I think this is pretty much going to be about it for me.
Yeah, for at least a couple years. I need a break.
That had an extremely frustrating only being able to work on it in 45 minutes.
Yes, it was really frustrating.
It was a constant stop and go, and planning takes time, so there were days where we'd figure out exactly what we'd want to be doing, and then we'd have to clean up. So we'd figure out what we're doing and then have to come in the next day and be like, okay, well, what did we discuss yesterday? Get on track with that, and then you get maybe 25 minutes to work because you were discussing, and then you're back to cleaning up, and it's a constant cycle of we don't have enough time, but we need so much more time. So
Mark, if you did it again, what process of welding would you choose other than what you say TIG?
yeah, definitely TIG. I know I'm not the most comfortable in it, but I think it probably would have been better than trying to do MIG on this, because TIG,
Gonna try it again with TIG?
not anytime soon. Like I said, I need a couple years to recover from this one, so. But yeah, so
Nice job.
thank you.
Good documentation.
We have a lot of documentation. That
Very
was
nice.
another, with timing and stuff, we'd get stuff done, take a couple minutes to take pictures, and then we'd have to work in between. It was just a lot of stuff on top of each other with very little time to do it. So it took 8 months.
Yep.
Yeah.
So you guys haven't gotten a grade on this yet?
No. We are going into NTC on May 2nd to
So
submit this for the competition.
This was like practice for that.
Yep.
Well, being here with you guys that day, we worked very well together. There was no yelling or screaming or tears flowing. You make a good team. So
Well, we try to keep it.
Obviously shows that.
We try to keep it civil. I feel like if one of us attacks the other, we're kind of. Yeah. Yeah.
How'd you do the coloring?
It had originally rusted over really bad, so we just took the wire wheels and the die grinders and just completely, little by
Polished it.
little sections. Yeah.
And that's how it came out?
Yeah. So.
Makes it look like it has like shallow water ripple effects on it. Like that. It looks really cool. We initially were gonna do like waves in the design, but me trying to make a wave did not really go out very well.
Yeah. No. Again, another learning experience. It's like I have all these plans, but working around what you thought you wanted to do and what you really can. So. But.
That's called thinking on your feet.
Yep.
And
Yep.
everybody that builds stuff, Michael,
Yeah.
confirm on that. I think you gotta stay flexible when you build stuff.
Yep.
Well,
Yeah.
I think it'd be safe to say that you guys have impressed everybody in this room. You know, so, nice job.